I'm still confused which one you're asking.
Because aren't we adding 1 over 1 minus x squared?
Oh, that's this.
Oh, that's the whole thing?
That's this. Yeah, this whole thing is this plus this.
Right.
And so I couldn't add them because my x's are different.
It's the 1 over, okay.
Oh,
You're trying to find what specific part.
So this term is the 1 over, it's this one.
Okay.
I wish when I had typed this up that I had reversed them, but, yeah. So anyway, so you get that. So anyway, this ends up becoming this. So you take the 0th term and just add it to the sum of 1 to infinity. Now we've got matching sums. If I lost you in that part, life's gonna keep going on. All right, so it really will. All right, so anyway, that being said, so now I can combine these guys. Remember that when you add sigmas, you treat them like terms. So it's n plus 1 x to the n's plus n x to the n's. So it is 2n plus 1x to the n's. Now, Joey, this is just for you. You could leave it like this, but wouldn't life be great if we could put this back together and start at 0? So if you think about it, the 0th term of this series is 1. So if because you get 1 times x to the 0, which is 1. So 1 plus this is the same thing as if I took it and started with 0. I know, all these things that you wouldn't think to do, I know. This was a lot. This is heavy. I know it's heavy. I know it's heavy. All right.
I can see why she
Okay. Hey, we're not done. So here's what we just found. We just found that this
You still have to multiply by x.
equals this,
You just do it.
right? But the whole problem was, what is x times 1 plus x over 1 minus x squared? So now we have to multiply it by x, right? So we take a second, we multiply by x. This x to the n becomes an x to the n plus 1, right? And there's your final series. Now, I also found the interval of convergence. Sorry, I had to move everything down, so it's all better. There. So I also found the interval of convergence, which is the same as if you treated this as a geometric series. And it is, I'm still not super comfortable with that. I haven't talked to Mr. Thomas about that yet. So I am still doing ratio tests just for my own personal comfort level until I can just convince myself it really is geometric. But anyway, so you end up with that based on. Okay. Yes, Tori.
When you did, when you did the step to the square, why did you drop the 1, the plus 1?
Oh, from here to here? Because I wanted it just. Okay. It just made it a nicer function. If we start this at 0, the 0th term is 1. And then, so, because you plug in, you get 1 x to 0, which is 1. So if I have this sum starting with 0, it's equivalent to this. And it's nicer. It's easier to work with. We're not done. You guys are all packing up, but I've got 2 minutes of your time left.
50 seconds.
Nope, we're going. Okay, in your homework tonight, in your book, there is a page with a list of well-known series. If you don't use the paper copy of the book, you can either find this in the Smartboard notes or you might want to snap a picture of it because you're going to need it for your homework tonight. I have one last thing to walk you through once you snap your picture.
Evan, send it to me.
Okay, everyone got it?
Isn't it already in the calculator?
Yeah, someone said.
Good.
Oh, hold up.
Yeah.
Oh, very good.
Okay, good. All right, so here's the thing. you're gonna be given a problem like this. And it says use a well-known series to see if you can get this. Up really quickly, -1 to the n over 2n plus 1. If you look at your series, arctan has -1 to the n over 2n plus 1. It looks like it, but there's no x's on every one. This is a function, arctan x. So you have to think to yourself, what are we plugging in to get arctan x? To get that, we're just plugging in a 1. If you plug a 1 in for x in your arctan function, you end up with an equivalent series. And so what you end up with is that this series is just equal to 1.
Social studies credit recovery will be awarded 131.
Alright, good, very good. We made it through the whole thing. Short day, big lesson, life is good.